Assalamualaikum. My name is Nur Amarina binti Abdul Aziz. My metric number is DF2000027. The element structure that I have choose is short span bridge, and it is located at Taman Rasnah, Kelang, Selangor. The material of this structure is reinforced concrete. For the next slide, I will explain about introduction of bridge. Bridge is a structure which covers a gap and play a very important role in the infrastructure of a country by reducing distance. Bridge is a structure corresponding to the heaviest responsibility and carrying a free flow of transport and is the most significant component of a transportation system. Bridge is the key element in a transportation system. It controls the capacity of the system. The bridge controls both the volume and weight to the traffic carried by the transportation system. For this slide, this is the idealization of the structure that I have sketched. Next, this is free body diagram. I have calculated the estimate of load, which is dead load and mass of beam. From this calculation, we will find total loading act on beam. Next, it is about support reaction. We have to calculate the moment and force for this structure. For the next slide, the figures show about the calculation of centroid. As we can see, there are 5 sections that we have to find of the area of the rectangular. And then from this table, you will get x equal to 6 and y equal to 2.25. After we find the calculation of the centroid, next we have to find the area moment of inertia. For the figure 1, it is x-axis, and the inertia is 22.85. For the figure 2, it is y-axis, and the total inertia is 404.96. The last slide is about conclusion. This structure, which is short span bridge, we can consider this structure is strong and stable. As we can see, the most important design objective is safety. Bridge must have adequate strength to support expected and unexpected load. Additionally, safety of the structure during construction must be considered. The support reaction, centroid and moment of inertia has been calculated, and the value for all of it are very logical, accurate and reasonable. Last but not least, in designing a big or small structure must be smart and careful in deciding material, size, strength and durability, because with all of these are very important to make sure the structure are strong and safe for users when use it for a long time period.
Hi, my name is Vivian Rahul Martin. My number metric is DF2040, and I will talk about structure column and beam, also called as frame. Introduction. Frame structure are the structure having the combination of beam, column, and slab to resist the lateral and gravity loads. These structures are usually used to overcome the large movement developing due to the applied loading. Column. The column is vertical structural member that carry load mainly in compression to support floor and roof beam, and the column of the floor above and then to the supporting soil beneath. Beam. The structural component can withstand load by resisting bending, and a beam is fixed at both ends and it's called as fixed beam. It not allow vertical movement or rotation at the beam. This is the picture. This is the picture. This location is at Melia Residence, Eastwood Park City, Miri. This is the idealization of the structure that I have sketched, where we can see beam and column. Free body diagram. This is the free body diagram that I have sketched also. Estimation of the load and action. I have assumed beam that the total weight of beam is 2 kN per meter. Length of beam is 10 meter. And to get the magnitude of beam is total weight of beam times length of beam, and we get 20 kN. This is the support reaction. To get the value at RB is MA equals 0, where here is the calculation, and we get RB equal to 10 kilonewton. For RA is Fy equal to 0, and here is the calculation that I have to do. Then we get RA equal to 10 kilonewton. This is the calculation of centroid. As we can see here, I have divided this structure into 3 sections to make our calculation more easier. After calculate the area x, y, ax, and ay, each section we will get the total area ax and total ay. And here we get x is equal to 3.2 meter and y is equal to 1.45 meter, and here we can get centroid. The area movement of inertia. This is the calculation of area movement of inertia. Here we get x-axis is equal to 1528.4 meter power of 4, and for y-axis is 339.4 meter power of 4. In conclusion, structure can be interpreted as a member that attach to each other with appropriate and secure connection to produce a framework capable of bearing the expected load. Second, the most important design objective is safety and the durability of the structure. Third is the support reaction centroid and movement of inertia have been calculated, and the value of all of it is very logic and accurate and reasonable. Based on the estimate calculation, this structure can be considered stable and strong, and the material that has been used in this structure is suitable for construct the housing.
Hello everyone, my name is Ronnie Elanana Richard. My matrix number is CF 2088. So I choose beam for my component of structure. Next, we go to description of the structure. So beam is structural component that can be withstand load by resisting bending. The bending force induced into the material of the beam as a result of the external loads on weight, span, and external reaction to this load is called a bending moment. So I choose my beam at my house. It is located at Lot 23, Taman Makmur, 95,000 Aman, Sarawak. And my materials, of course, for housing, it is cement. So I chose this beam as my component. Next, we go to idealization of the structure. First, I draw free body diagram like this, and I simplified it like this, like this one. So this is not RYX, this is RBX. Okay, so RAX equal to RBX is 0. Both are the same. So the load is 20 kilonewton. As I mentioned, estimation of loadings or action. So I assume that my load for beam is 20 kilonewton per meter. So length of the beam is 6 meter length. So the magnitude, I guess, is 20 kilonewton per meter times by 6 meter is 120 kilonewton. So my problem is become simply support beam with the load, with the point load is 120 kilonewton in the middle. So this my support reaction according to the formula, RAY plus RBY is 120 km. So why we get this? 16 kilonewton times by 2, it also become 120 kilonewton to determine it is on the middle or not. So my centroid is like this. I forgot to mention my height. I assume my height for beam is 0.5 meter. I calculate it into this table. 6 times by 0.5 is 3, and so on. So therefore, is my x is 9, and my y is 0.75 meter. Both are meter. So my moment of inertia, x-axis, as you can see, is my section is one, is 1, and also my path for the center is also 1. So uh, I can simplify it. Uh, so my ix is 0.0625 meter. My dy is 0 and my dy is 0. So y and y axis. My section 1 is my ay is 9 meter. So my dy is still 0, and also my dx is 3. So ay is 9. So for the conclusion, is based on the estimate calculation that has been made, we can consider that this structure is strong and stable. The material that had been used for this structure is suitable for housing design. This is a very common design and easy to build, even though the size of it is big. The support ratio, centroid, and moment of inertia have been calculated, and the value for all of logical according to estimation and reasonable. So that's all from me. Thank you.
Hai, Assalamualaikum. My name is Nur Zairita Zulaika binti Muhammad Zailani. My number matrix is BF2000337. The location I choose is Taman Falim Ipoh Perak, and the structure I choose is cantilever slab. Okay, second slide. Introductions to cantilever slab. A cantilever slab is a rigid structural element that extends horizontally and is supported at only one end. Typically, equal surface such as a wall to which must be firmly attached. Like other structural elements, a cantilever can be formed as a beam, plate, truss, and slab. When subjected to structural load at its far unsupported end, the cantilever carries the load to the support where it applies a shear stress and a bending moment. Cantilever constructions allows overhanging structures without additional support. Okay, next. This is my free body diagram of the cantilever slab. Okay, my load is 30 kilonewton per meter and my length is 5 meter. So we have to make UDL calculations. So this is my calculation. The calculation is loads multiply the length. So I get 150 kilonewton. Okay, next. Here I want to show the calculation of the support reaction of the structure. So first of all, we have to calculate axial force at point A. So Fx is 0. Fy we get 150 kilonewton. And then we have to calculate moment at point A. So the formula is F multiply D, 115 kilonewton multiply 2.5 meters. So we get 375 kilonewton. Okay, next, we have to calculate centroid of the structure. As we can see, we have two sections at here, section 1 and section 2, which is two rectangular. Based on the table, we get area 33.45 and we get x 2.81 and y 5.15. Okay, next. After we get the calculation of centroid, we have to find out area moment of initial x and y. So, after the calculation, we get initial of x is 153.17, and we get the moment of initial y, we get 147.28. Last but not least, conclusion, we can conclude that static is a very important thing to take before starting a building construction work at site. It aims to study and understanding the different type of cantilever and effect of different factors in deflection of slab has been completed successfully. Structures can be interpreted as members attached to each other with appropriate and secure connections. The load imposed is different from building to another because of different use, and this requires a true structural studies to each building. Last but not least, before building is built, a true study will be done. The designer to ensure the structure of the building is able to bear the load that will be imposed on the structure. Thank you.
I'm Kavile, son of Kanakan. Now I'm going to present about roof structure. Introduction. Roof is a part of a building envelope which is the covering on the uppermost part of the building or home. The outer layer of a roof varies depending on the availability of material and the nature of the supporting structure. The process of the building and maintaining the roof is called as roofing. I have chosen guardhouse roof of Polytechnic Sultan Idris Shah for my project. This is the free body diagram of the roof. Support reaction of the roof truss. From the analysis of reaction, I have got 1250 Newton for both RAY and RBY. I have calculated the centroid. Before that, I have divided the roof into two, which is left section 1 and then right section 2. And I have got x-axis 3.39 meter and then y-axis 3.26 meter. Moment of inertia of structure. For x-axis, I've got 87.9 double meter square. For y-axis, I've got 78.01 double square meter. Conclusion. The structure or building is guardhouse of Polytechnic Sultan Idris Shah. By seeing the calculation for the body diagram, support, reaction, centroid and movement of inertia, we can conclude that the structure of truss inment that allows the weight of the roof to be distributed to the outer wall or columns for better support. The engineering principle behind the truss, the shape of the triangle or series of a triangle. In a geometry, a triangle is very strong and can withstand the different load better than other shapes. In architecture and structural engineering, a truss is a structure comprising one or more triangle unit constructed with straight members whose ends are connected, a joint referred to as nodes. Thank you.